What we're going to go over is the continuation from the last video with the special right triangles and how this trigonometric values of sine, cosine, tangents of these angles affect the ratios in quadrant 1, 2, 3, and 4. Um, Before we dive into that topic, I really strongly recommend you to watch the video first and make sure you understand where these values come from. The formula for 45, 45, 90, a root 2, a root 3, a and 2a. Basically, to sum up, it's a split of a square for 45, 45, 90, and the split of a equilateral triangle for 30, 60, 90 degrees. And no matter what type of values you have, the sine, cosine, tangent value of small 45, 45, 90, or even really big one, they're all going to be the same. And same thing for this one because they're all similar triangles. Um, the first thing we're going to be taking a look at is we're going to be looking at the 45, 45, 90 because it's going to be easier to deal with. So I'm going to erase this part. Now the unit circle that they have provided for you here, I would like you to take a look at this one. And notice that the values are going to be a little bit different from what we're used to. The formula that I would always like you to remember is 1 square root of 2. But in the unit circle that they gave you here, they gave you square root of 2 over 2, square root of 2 over 2, and then 1. The only reason why that is because they made sure that the hypotenuse will always be 1 because that's what unit circle means. Unit circle simply means that the radius has to be 1. So instead of calling this square root of 2, they, like this one here, they call this a 1. So how do we figure out the rest of these values, square root of 2 over 2 and the square root of 2 over 2 here, is that you just simply have to divide everything by square root of 2 from this triangle. And then you will eventually find out what these values are going to be. So if you divide this by square root of 2, you're going to simply get a 1. But that means that you have to divide everything by square root of 2. And notice how this and this are still going to be different from each other. The only reason why that is because they forgot to rationalize it. Rationalizing it simply means that you just have to take a square root of 2 and then multiply by itself to the top and the bottom. And the reason why they do that is because the denominator will no longer have a square root in the denominator. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4, but that's same thing as saying 2. And that's where this value came from. Same thing happens here because it's exactly the same thing. Now once we establish that, let's take a look at these values in the table. So this is the worksheet that you guys all have to fill in. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And also, I strongly recommend you to watch the video for the part where I'm talking about the unit circle, is that your x and y will always follow cosine of theta and sine of theta. Okay? So, when we talk about these values, this really doesn't apply to this circle here because we have divided essentially everything by square root of 2. And by doing so, we have essentially divided by what we call the hypotenuse. But besides that, let's forget about all that and then go straight to the topic here. Okay? So, if we're talking about the first quadrant, let's take a look at the first quadrant here. This coordinate right there will be x, comma y, which is square root of 2 over 2, comma square root of 2 over 2. And because we have talked about how your x value is always your cosine and your y value is always your sine, you can take those two values and just literally write it down here and here. And that's where these two values came from. Now, how do we find tangent? Well, tangent is simply sine of theta over cosine of theta, or tangent is always opposite over adjacent. So if you take a look at this triangle here, opposite side is this, and your adjacent side is this. When you take a look at those two sides and when you take the ratio of those, notice how they're exactly the same. So square root of 2 over 2 over square root of 2 over 2, well, they will cancel each other and just become 1. And so that's why the tangent of 45 becomes 1. Okay? Now the part that gets really tricky is starting from different quadrants. The only thing that I want you to remember from this point onwards is what is going to be my sine. Okay? Because I guarantee you the numbers, okay, this is the easy part, the numbers will always be the same. The only part that's going to be different are the signs, because the first thing that they tell you here, if you read the instruction, below a 45, 45, 90 has been inscribed inside a unit circle, which we see in the first quadrant here. But it says to sketch the result of reflecting triangle across the y-axis. So what we're going to do is we're going to take this triangle, and then we're going to reflect it. I don't know if I can, well, if we do, oh, that's going to be delete. And then what we're going to do is we're going to reflect it across the y-axis, and it's going to become like this, because that's how reflecting across y-axis would represent. Now, the 45 degrees will stay the same. This will stay the same as root 2 over 2. This will stay the same as root 2 over 2. Everything will be preserved, except that this angle right here would be 45 degrees. Now, the first thing that they ask you to do is, what is going to be my angle? You guys always must understand that the angle starts from the 3 o'clock position, and it ends the terminal side at this radius right there. So that is the angle in purple that they're talking about. Well, if you know that this part is 45, how much is it left to make this whole thing to be 180? Well, 180 minus 45 should do the trick, right? Which gives you 135. And that's exactly what we're going to put in the second quadrant, 135 degrees. Notice how they give you the intervals. Between 90 and 180. Well, 135 fits right in there, doesn't it? So I know that I'm in good shape. So now that I have found the angles, what do I do with the values? Control C, Control V. I hope you guys know what I'm talking about. Just copy and paste all of this. I guarantee you that will be exactly the same. The only thing that's different about this is the signs, like I said. So what do I do with the signs? Well, take a look at where this triangle is positioned. Your x value is this way, and your y value is this way. So is your x value positive or negative? Well, it turns out that it's negative because you're going in the negative direction, right? The xy coordinate plane, it always turns out that if you count this way, it's negative. Your y is positive. And what did we say before? Cosine is always your x, sine is always your y. So cosine ends up being a negative in this case, and sine ends up being a positive in this case. So that's the only thing you have to worry about. And you just apply it right here. So cosine ends up being a negative, sine ends up being a positive, and so sine of 45 degrees, which is this one, so sine of 45, actually ends up being the same thing as sine of 135. And you can type this in your calculator and see in degrees mode. Please make sure it's in degrees mode. You will get the exact same thing. But if you type in, let's say, for example, cosine of 45 is equal to cosine of 135, you're not going to get the same number. Yes, it will give you the same number in terms of like decimal wise, but it's not going to be the same sign. The sign will be different because this will turn out to be negative and this will turn out to be positive. And that's the only thing you have to worry about. So that's negative, that's positive. Now, about your tangent. Remember what I told you before, that tangent is simply sine over cosine. So you take a look at the signs, for example. Sine is positive on the top, divided by cosine is negative on the bottom. What's positive divided by negative going to give you? It's going to give you a negative sign, right? So then tangent will also end up being a negative because one of these guys is going to be negative. Let me just erase this so you guys can have a better understanding. There we go. So that's sine is positive, cosine is negative. Okay? All right, so now let's take a look at quadrant 3. For this one, I would like you guys to pause the video now and then try the angles on your own. Remember, the triangle that you flip over is this direction. Sketch the resulting reflecting the triangle across the x-axis. What they mean by that is they want you to take this, I call this a purple triangle. Take this purple triangle and then reflect it across the x-axis, so it should look like something like this. And that's going to be where your terminal side ends, and it's going to be in quadrant 3. Tell me where the angle is and what these three things are going to be. Remember, what did I say? Control C, Control V, right? And just worry about the signs. Pause the video and please finish it up and then play it again once you're ready. So I hope that you guys have the answers here. Is that this answer here will be 225 degrees. Then the reason why that is because it always, like I said, starts from the 3 o'clock position. I know it's getting super messy here, so I'm going to erase all this stuff. Okay. It starts from here, and it ends up being down here. This is 180 degrees, and this is additional 45 degrees that you have to add. So it looks like a little bit of a, I don't know, like one New York slice pizza taken away from a pie. But it doesn't look like a Pac-Man per se, but it looks like this. So it's 180 plus 45, so that should give you 225 degrees. Okay, and that's your triangle. Well, I should probably use purple just to indicate purple triangle right here. Remember, this is square root of 2 over 2. Square root of 2 over 2 is 1. That value should never change. But what's changing is always the sign. Your x is negative direction, your y is negative direction, so both of these are negative. So you control C, control V, all of these values as it is. Okay, they will never change. But what happens? Sine is negative, cosine is negative. That's it. Well, what happens to your tangent then? Well, tangent, like I said, was what? Sine over cosine. But if they both turn out to be negative, what's negative divided by negative going to give you? Yes, it's going to be positive here. So that is how we know that tangent is going to be positive in the third quadrant, but sine and cosine won't be. Here's a little trick. Quadrant 1 will have everything to be positive. That should be said without a doubt. Starting from quadrant 2, 3, and 4, only one of them is positive. So for example, sine was positive here, tangent was positive here, and hopefully that should give you an idea as to where the positive value will be in the fourth quadrant. I'm going to leave this blank and for you guys to be able to solve, but make sure your angle is between 270 and 360. The final angle, it says to sketch the result of reflecting triangle across both the axis. Well, you don't have to do that. You just take this purple triangle and reflect across the y-axis, and it should look like this. That should be the last triangle that you should see. And so this angle, where is it going to be? What is your x and y what are your x and y coordinate values? Is x positive or negative? Is y positive or negative? Determine that and please finish this up. This should be for the grade. Okay, now the 45, 90 degrees is out of the way. Let's take a look at the 60 degrees. The 60 degrees will be a little bit slimmer, and it's not going to be equilateral triangle, so you have these three separate values. Okay, and where do they get those from? Well, remember when we recall the 30, 60, 90 degree triangle, okay, we said the opposite from 30 degrees was A, and opposite from 60 was A root 3, opposite from 90 was 2A. When we divide every side by A, what essentially happens is we get 1, because A divided by A is 1, square root of 3 and 2. But look how the radius, again, this radius has to be a 1. So what does that mean? I divide every side by 2. And notice how that value is right here. That side is right there. It's as simple as that. You don't have to worry about where they get those values from. It simply comes from the notes that you have seen at the very top. It comes from this formula, just a little simplified. Don't panic. So after we found out the 60 degree side here, notice how sine and cosine, like I said, x is always your cosine, y is always your sine. So this is your x value, which is 1.5. Y value is square root of 3 over 2. So sine is your y value, cosine is your x value. And where do they get the square root of 3 from? Well, you can do this two ways. Number one, you can take a look at this triangle and go, okay, I gotta take opposite over adjacent, right? So square root of 3 over 2 divided by 1 over 2. Well, essentially that's the same thing as saying sine of theta over cosine of theta, like I said, right? Because you take this value and divide by this value. Keep, change, flip. Hopefully you guys learned that in 5th grade. Square root of 3 over 2. Keep, change, and then flip the second fraction. The 2's will cancel out, and square root of 3 over 1, well, anything divided by 1 is just by itself, so that's where the square root of 3 came from. And notice how they're all positive because we're in the quadrant 1. Starting from quadrant 2, quadrant 3, and quadrant 4, like I said, only one of them should be positive. And the angles here should all be within these intervals that are given. Okay? Those are the facts that you always have to keep in mind of. So, the second quadrant. You flip this triangle across. I'm going to use blue here. It's going to look something like this. So that should be 60, which means this angle that starts from the 3 o'clock position all the way here, how much would this be? Well, that's 180 minus 60 because you have to take this part away and get the rest of this in purple, and that's 120 degrees. So I'm going to write 120 degrees right there. Okay? So quadrant 3, what do I have to do? Quadrant 3, I have to take the 180 and I have to add additional 60 degrees. I hope you guys are noticing the pattern. So 180 plus 60, that should give you 240 degrees. From up here, what we did was for quadrant 2, we did 180 minus the angle 45. This one we did 180 plus the angle 45. And for 360, I hope I'm going to tell you this right now, it's 360 minus the theta because that's how much you're taking away to go to the rest of it. Now here, if you use that formula again, 180 minus 60, 180 plus 60, and 360 minus theta, you should all get the answer. And then these three values, what was the magic step that we do? Copy and paste it. Just take square root of 3 over 2, 1 over 2, square root of 3. You can just do this for all the table values here. I'm still going to leave this blank, but you guys should know what to you guys should know what to do. What do you always have to worry about? All you got to worry about is the signs. But from the first table, like I said, what's going on here? Okay. Only thing that's positive in the second quadrant is sine. The rest of it is negative. Only thing that's positive in the third quadrant is tangent. The rest of it is negative. So I can apply the same rule here. It doesn't change. So quadrant 2 would be positive only for the sine. The rest of it would be negative. Quadrant 3, only tangent is positive. That means the rest of it is negative. And for quadrant 4, I hope you guys realize that cosine is the only one that's positive. The rest of it is negative. Okay? So please finish that as well. For sine, cosine, and tangent value of 30 degrees, because I have probably repeated myself for many, many times, I think you guys can do all of this on your own. Reflect a triangle this way, and then this way. But use these formulas up here to find the angles. Here, here, and here. And then the rest of it, what do? Copy and paste it, and just worry about the signs. 3 reflection questions. What do you observe about the absolute values of trigonometric functions? Don't focus on the absolute values too much. What do you notice about the trigonometric functions of any row on the table? Row is this way, right? So what do you notice about sine of 30 and sine of the other angle in quadrant 2, quadrant 3, quadrant 4? Well, I think I told you, copy and paste this, so you guys should know what that means. Identify which quadrant have positive values for sine, which have negative values. Do the same for cosine and tangent. Again, that's basically what this portion was about. In which quadrant is it going to be positive for sine? Which quadrant was positive for cosine? For quadrant 1, everything is positive, so we don't really have to worry about that. But for quadrant 2, 3, and 4, it gets a little bit tricky. How do the sine lengths of the triangle's legs relate to the point where the triangle intersects the unit circle? Use this to relate the coordinates of the intersection points to the trigonometric functions of the angle theta. So the sine length simply means negative or positive. And to the point where the triangle intersects the unit circle means that on the unit circle, we have the coordinate x comma y all over these values. I hope you had seen these chart before. But basically what ends up happening is when the xy coordinates are positive or negative based on that, your sine and cosine value also becomes either greater than 0, positive, or less than 0, negative. Because, for example, sine is still positive because your y value is positive. This is basically talking about how cosine of theta is x and sine of the theta is y. So you know how y value is positive only up here, first and second quadrant, but sine of y value is negative down here. So that's why in the first and second quadrant, sine is positive, and we can also see that. But sine is negative on third and fourth quadrant because they're below 0. The y value is going to be negative. So you need to make some sort of a relationship to that, how the xy coordinates relate to the cosine of theta and sine of theta, and then you can just write down your answer and do your reasonings from there. Hopefully this video helped, and make sure that you understand the unit circles and how to get the values, because eventually what you guys are going to be asked to do is compute at any single moment what is sine of 200 and, for example, I don't know, 225 degrees is going to be, and you have to tell that to the teacher right away, because that's what this is about. First of all, what's the sign? Well, make sure it's negative because we're in the third quadrant, and those kind of things. And what's the value? Square root of 2 over 2. It should come out right away. Now, if you haven't memorized a unit circle, which I strongly recommend you to not to, just remember that the patterns always repeat. Only thing you have to worry about is the signs. Just memorize the first quadrant and just reflect it across, and that's the fastest way that I can kind of give you a small hint for. Hopefully this video helped. Please finish this worksheet, and hope to get to see you soon. Thank you and have a nice day.